Hello everyone, this is Harsha from Midas IT. A very warm welcome to all of you in the course of tunneling using Midas GTS NX. Basically deals with the numerical analysis. Myself, Sri Harsha, I'm a geotechnical engineer in Midas. In this pandemic times this is like one of the difficult times faced by the mankind ever, and so hope we will be coming coming out of this in a sooner time. And but still we should be get ready for ourselves for the future, and by equipping with some knowledge and it, right? So in an effort towards that, we are offering this short course on tunneling using GTS NX, and it's like complete numerical analysis of tunnel using GTS NX. So now I think it's clear, my voice is clear and you can able to hear me, right? Yeah, fine. So please stay safe and healthy, and yeah. So this tunnel course, basically it is going to deal with most of the numerical like a numerical modeling and analysis in tunnels by considering various modeling techniques of tunneling, taking into account various physical constraints. Like I will be giving you a brief idea about all the topics that are that we are going to cover in the entire session, like in the entire webinar series. Like mitigation of the inevitable risks involved in the tunneling will also form an important parts of the course. Like there are different types of vulnerable areas when we go for tunnel excavation. So we will be dealing with each and everything of it, and we will come to know what is the basic idea behind everything, and why we need to go for a numerical analysis. So the very first session, it's like getting started with GTS NX, and this is our current session. In this session, I will be giving you a brief idea about the tunnel construction method, and then I will be giving you a brief idea about the GTS NX on a whole, and then why 3D analysis is more required and why it is important. So I will be giving you a brief idea about all these things. And in the second session, it's like a twin metro tunnel in a layered soil. So when we go for urban areas, like cities where we go for metropolitan cities, nowadays the metro construction and metro tunneling is like quite common. So it is like a continuous, we can find most of the uniform soils, and it is like a continuous in a straight line. So we can consider as a plane strain condition, and we can go for a tunnel analysis. And it is not a single tunnel. We can find two tunnels with like 30 to 50 meters of distance. So we will deal with the twin tunnel metro in a layered soil in the second session. In the third session, we are going to deal with the construction stage analysis of simple circular tunnel with shotcrete lining. So basically, it's like an extension towards the second session. So in this session, we are actually dealing with the excavation sequence. When there is an excavation being done, what is the deformation in a construction stage? So next stage, we are going to apply a shotcrete. So what could be the behavior of the soil? So we are dealing with in a 3D scenario, so that the real construction sequence, which affects the results, is being considered in the session 3. And when we go for session 4, we are having a quick modeling and analysis of a horseshoe tunnel with lining and rock walls using Tunnel Wizard. So actually, GTS NX is equipped with a beautiful wizard called Tunnel Wizard. So using this wizard, you can able to model the complete tunnel within no time. Actually, you're not modeling the geometry, you're not modeling the, you're not providing the mesh, you're not actually providing the construction sequence, but actually you are providing in the form of inputs. So we are inputting the dimensions, we are providing the mesh size, and the software, the wizard, will provide you with the model as an output. So we'll be dealing with all these conditions now. Sorry, I think you're able to hear me, right? So I can find some restraints are telling you're not able to hear this. Yes. Yeah. Okay. Fine. Okay. Let's continue the session. So in the next session, we are dealing with the D-shaped railway or roadway tunnels in a hilly terrain. So whenever we go for hilly terrain and whenever we find railways and roadways, it's like an a strategic importance, or it's like an complete different guidelines provided for these railways and roadways. So when accordance with the Indian railway tunnels, so they will provide you with a specific guidelines, and they will provide you with a D-shaped, they will be providing you with a specific shape of the tunnel as well. So in this session, we'll be dealing with how to model the entire D-shaped tunnel in a 3D in an hilly terrain. So we will be modeling the slope, and whenever you find a slope and whenever you're excavating it, the opening of the tunnel, you can find a slope failure. So it's vulnerable for a slope failure. So in such a cases, how to add a slope stability analysis in even the construction stage analysis will be dealt in this session. So in this session, we are going to deal with the construction stage analysis of a D-shaped tunnel, as well as the slope stability analysis. And then in the next session, we are going to deal with a double line tunnel modeling. So in most of the tunneling methods, let's say in a sequential method, or let's say an NATM method, we actually deal with two linings. So we provide a primary lining, we wait and see the response, and after some time we provide a double like secondary lining or a final lining. So we will see in GTS NX how to model double lining in GTS NX. Also, it is in 3D once again. In the next session, we are going to deal with the construction stage analysis of tunnel with cross passage using stage visit. The basic idea is why we go for 3D is so we cannot model an intersection in 2D. And then because of this intersection, actually it is vulnerable for failure. So in this session, we are going to deal with how to model the tunnel and how to model its cross passage, and how to check the results, and how to find the capacity curves at the section as well, at the intersection, and we will see whether it is going to satisfy our norms or not. And in the next session, we are going to deal with the deep excavations for metro station. So whenever you deal with metro stations and metro tunnels, basically it's in urban areas. So there will be a lot of buildings together, and we don't have the contractors or consultants don't have much choice to go for the type of excavations or type of lateral support. So we cannot go for secant pile wall every time. We cannot go for like a D wall every time in an like metro station deep excavation. So in this session, we are going to deal with the lateral support system, basically D wall, along with wallets, along with struts, and along with anchors as well. So we will be dealing with these conditions in session 8. And in the next session, we are going to deal with the lowering of TBM shaft into the tunnel. So it's nothing but shaft sinking. Basically, for any tunnel boring machine, you need to have an exit shaft and as well as entrance shaft. So in this session, we are going to deal with this intersection, how the intersection is vulnerable, the tunnel and the shaft intersection, and how we are going to deal with the construction sequence of both tunnel as well as shaft in this session. So in a nutshell, this is all about the complete tunneling course in GTS NX, which we are going to offer you. Yeah. So I think most of you are being given with the link and the license for 3 months. So I will be telling you how to activate the license. And those who didn't find the links and those who didn't receive the email for a 3-month license, I will urge you to go for our Midas website, en.midasuser.com. I will be giving you the website name as well. Just go there and register and get the trial license. So in the Indian business area has been given with the 3 months license. So please download the software, and then once you downloaded the software, you can find an option called, so you can find a command with the name options. Just go to the options, you can find a new tab. So in this new tab, you can go to license. So in the license, you you can find two authentication methods. One is standalone and other is a web authentication. So in this web authentication, you're being given with the web license. So all the registrants who are being given with the license, it's a web license, go to web authentication. And those who are going to download once again from en.midasuser.com, even though those are also will be given with web authentication. So please go for web license. So once you go for a web license, you need to yeah. So you go for web license. Sorry. Yeah, so once you go to web license, and then you need to enter your user ID and password. So you can create your user ID and password in en.midasuser.com. In the same website, you can download the software as well. So just use the same user ID and password in the in these columns as well. And then once you proceeded, you will be having your license already with you. So the protection key as well as solver key. Please enter your protection key and solver key. So later on, you just press on options. In the options, you can find pre-post and the solver PIDs. So in the drop-down menus of both your pre-post and solver, just select the PID that was given with you, and then go for selection all. Actually, you're being given with the advanced the license, so that all the options will be on. So you just select all and then press OK. So your complete license will be activated. So let's start with the presentation. As I said, our presentation for today will be dealing with like this following contents. So I will be dealing with the tunnel construction method, and then the procedure, like what is the procedure from starting to ending for the tunnel construction will be dealt in a very brief way. And then we go for why 3D modeling. So why 3D modeling is required instead of a 2D, and where and all places we need to have a 3D modeling. And then I will be giving you a brief introduction about GTS NX and then its project applications. So whenever we are having a tunnel project, so this is what we go from top to bottom. This is the procedure which we go the authorities are decided to have a tunnel at the particular place, and they are already decided with the dimensions of the tunnel and the place of construction. So now it's up to the consultants and contracting team to proceed further. So the very first thing which we go for an tunnel construction method is investigation. So we will go for a geotechnical investigation, geological investigation, as well as hydrogeological investigation. So these three plays a key role in any tunnel design. And then we go for construction method. So there are many methods. So we choose the type of method, whether it is a tunnel boring machine, whether it's an NATM method, whether it's an a drilling and blasting method. So we choose the construction method, and then we decide, we go for preliminary designs. So there are many approaches to go for preliminary designs using empirical theories. I will be just dealing with a few of them. And then we go for numerical analysis and design. So in the numerical analysis, we basically we model the complete tunnel in the software, and we go for analysis to see whether the convergence is correct or not, whether the bending moment diagrams, whether the capacity curves which we are going to draw, all the results from the numerical analysis will be interpreted, and we draw a capacity curve. So we'll be dealing with these capacity curves as well in the upcoming sessions. And then we go for construction. So we use the type of construction method, and we go further for construction in a site. So in the preliminary design, basically whenever you are going for rocks, so your the authority has been already decided for a tunnel, and in rocks you're going to use a queue system. And for a soft grounds, basically there are many design guidelines. We basically use it for to control the tunnel loss, like volume loss, and you can go for common design guidelines by ITA as well as WSSC. In the construction method, you are having different construction methods. You will be having a cut and cover method and bored or mine tunnels. In bored and mine tunnels, we got a sequential excavation method, tunnel boring machine, as well as NATM method. So NATM method, rather we can call it as an NATM philosophy. So these are all different methods for construction. But in this complete short course, or in this complete webinar series, we are dealing with the numerical analysis and design using GTS NX. So basically, your construction method, which you are going to choose, will affect the results in the numerical analysis as well. As an earlier, what we do is we use it to model a tunnel. All the supports of the tunnel, like let's say soil surrounding it, will be given as a soil springs, and then we apply the overburden pressure and all the other pressures and all the other loadings, and then we run the analysis to find the results, displacements, as well as all the other structural forces. But basically, we need to model it as an 2D model or a 3D model using a soil on a hole, because we need to know the construction method, because this construction method will have an effect in the numerical analysis, because we are going to deal with the construction sequence, and that construction sequence will depend upon the construction method. So like it is always better to model your analysis or numerical analysis with your methods completely incorporating in it. So we are going to deal with the numerical analysis and design in this complete webinar series. So the very first case is we got a cut and cover method. So in the cut and cover method, what we do is we are going to actually excavate it to a deep, to a greater depth. Let's say this is actually used for a shallow tunnels. We excavate it, we provide the tunnel linings, we provide the walls, and then we again backfill it. So this is a simple procedure where we go for cut and cover method. And then we got another method that's called TBM method. It's called tunnel boring machine. In this method, what we do is we actually use a tunnel boring machine. So this machine is having a face which is having a cutters, and then it will actually drill and go further. It actually cuts the either rock or soil present in that area, and the mud will be carried towards the end of the shaft using the conveyor belt. So, and then we are having certain procedures and certain machines to actually go for the tunnel lining, as well as grouting techniques. And then we are having another model called NATM. In this NATM method, this is like a new Austrian new Austrian tunneling method, which is rather new, but actually we can call it as a philosophy. So even this method is widely used nowadays. And yeah, we go further. So whenever we deal with a preliminary design in rocks, we use a Q system from Barton. We actually calculate the Q rock mass quality, and then we know the span or height of the tunnel, and then we use this value as well as the rock mass quality to get to the type of rock which you're dealing with. So that let's say if you're matching this projecting your values, and you went into 4. So let's say you're in a 4 area. So in the 4 area, you can have the type of reinforcement. It's a systematic bolting and unreinforced shotcrete, 4 to 10 centimeters. Suppose if you go to 9, you can have cast concrete lining. Basically, this is an empirical approach in order to deal with the support linings. And then once you're done with the preliminary design, and you go for the numerical approach, so you run the analysis, you get the results. So here you run the analysis, and what you do is you get the results, and that results will be actually taken for a capacity curve. So the concrete will be having certain strength, and using those concrete inputs or concrete lining or steel lining, we are going to draw an capacity curve. And if our values from the structural forces of a numerical analysis, if it comes under the capacity curve, then it is going to it is going to be safe. And then now the next step is like why 3D. So we are having an habit of going for 2D analysis, and in most of the cases we go for 2D analysis. And why we need to go for a 3D analysis, we'll be seeing that now in this section. So although there are many geotechnical problems that can be approximated to either plane strain or axisymmetric. So we are having two different other than 3D modeling, we got a 2D plane strain modeling and axisymmetric modeling. So most of the geotechnical problems can be approximated to plane strain or axisymmetric problems, but many remain as a 3-dimensional itself. So what are the different areas or aspects in this particular tunnel analysis which needs to be considered as a 3D? I will be dealing with them now. So let's say we are having a single tunnel and we are excavating it, and there is a uniform soil. Let's consider an uniform soil throughout. So in that scenario, we can consider it as a 2D modeling, but why we need to go for 3D is because whenever you're excavating a soil, it is now into a secondary stress state, and you can experience a longitudinal arching as well as a transverse arching. So in order to cope up with that, we need to consider it as a 3D modeling. So that's why you need to actually excavate it based on your construction sequence and then get the results appropriately. And then in next scenario where we need to go for 3D is a tunnel intersection. In most of the metro tunnels, and there are many guidelines like after this much of length, like let's say 1 kilometer, 1.7 kilometer, we need to have a cross passage. So here the cross passage is basically a vulnerable area. So here we cannot consider a 2D case. So what we do is we need to model it in a 3D scenario, like we are having a main tunnel and we are having a cross passage, and this is like an extra lining section provided for the intersection case. So because that is vulnerable, hence we need to provide a different length. So after analysis, you can find that most of your intersection is actually like having more displacement or more stresses being concentrated at that particular intersection. So we'll be dealing with them with the tunnel intersection as well in session 7, I guess. Yeah. And then the next scenario where it is always better to go for 3D is shaft and tunnel intersection. So it is always known that shaft entry and entry shaft and exit shaft will be there for a tunnel boring machine, and from this shaft you are going to like a start or end the tunnel. You're going to put your tunnel boring machine from the shaft, and you're going to like take off the tunnel boring machine from the shaft. That is your basically end and start tunnel, start shafts. So whenever you find this shaft and here tunnel, actually this is also vulnerable because you can find a longitudinal excavation as well as vertical excavation. So this is also vulnerable areas, and we will see how the construction sequence as of a shaft as well as construction sequence of tunnel are going to affect your numerical analysis cases. We will be dealing with them in a shaft loading, the very last session. So we can model like this with the shaft, and we got tunnels as well, and because of this we can find the vulnerable areas and how the displacement contour is getting completed. uh, yeah 1 minute, I'm having certain queries from certain registrants. No need to worry about the license key. I will be repeating about the license key and how to activate them once again after the session. Yeah, I will continue with the session. So another scenario where we need to go for a 3D is tunnel openings in hilly terrains. Suppose let's say we are having certain tunnels like a strategic importance or a railway roadway. Strategic importance, when I say, it's like a tunnel for oil storage or some equipment storage as well. So here in a hilly terrains, what we do is when we are having a tunnel opening in here, and for this tunnel opening, we are actually cutting the hilly slopes. Based on the soil property over there, we can find a complete a tunnel face or complete slope getting into a failure or vulnerable for a slope failure or a landslide. So what we need to do is we need to most of the procedures, like we need to cut a section, regular sections, and we need to find a slope factor safety. But it is always better to go for 3D slope stability analysis because it is the shear plane which can be of only one tunnel or another tunnel or two tunnels on a whole. The shear plane can be of the entire area. So we need to concentrate on a 3D slope stability analysis in this scenario as well as a tunneling sequence. So we will deal with them here in this analysis in this session in D-shaped railway and roadway tunnel in a hilly terrain. Yeah, another scenario is where we can find extreme geology, like a faults, lenses, as well as a joint planes, which is forming a wedge over there. So in that cases, we cannot go for 2D modeling. We need to go for a 3D modeling. So in these scenarios, it's always better to go for a 3D modeling. And this type of scenarios will be covered in in the upcoming sessions. And now we'll deal with the GTS introduction. Uh, Sorry, some people cannot able to hear or cannot able to see the slides. Is it so, or so? Can you able to see the slide moving, or can you see? Can you hear me? Yeah. So I think most of them are able to hear. So those who are unable to hear, it's because of the internet issue at your end. So I think everything is fine from my end. Okay, we will go for GTS NX introduction. Yeah, so GTS NX is like a complete finite element platform where you can go for axisymmetric modeling, 2D modeling, and 3D modeling on a whole in a one single platform. As I said, all the geotechnical problems can be categorized under three. Like one is axisymmetric modeling, other is a 2D modeling, and other is a 3D modeling. So all these three types of modeling can be covered under one platform, that is GTS NX. You can get that axisymmetry, 2D modeling, and 3D modeling in one software itself. And then this is how the graphic user interface of the software looks like. There will be a certain workflow which I will be dealing with in the upcoming slide. In any software, you will be having certain workflow in the upcoming in any software. So here we start with the geometry, we proceed for material and meshing, and we choose the type of analysis, we analyze, and we get the result. So this is your ribbon menu. All the tabs and all the functions are related to this particular geometry are incorporated in the geometry tab itself. And the meshing and property are incorporated in the meshing tab. So what you do is you start from geometry and proceed towards right. That's how you can complete your complete modeling. And this is your work tree. Whatever work you do from starting to ending will be registered over here. And it's like a multi-window case. You can actually run any number of models in a single a laptop. It's not restricted to one single model at a time. You can run n number of models, and n number of models can be analyzed at the same time. So the only thing is hardware restriction. So depending on the hardware, you can model n number of models. So this is how the work process in Midas GTS NX looks like. So what we do is we get the geometry, we import the geometry, or we create the geometry, and then we go for materials. So based on the materials present in the site, we input the materials and we provide certain property to those materials. Whether it's a 3D property or whether it's a 2D property, we basically decide and provide certain property to the materials which we are going to assign. And then we mesh the geometry. So while meshing the geometry, we will assign certain materials to the geometry. So that's the fourth step. We are assigning a material while meshing the geometry. And then we go for a load and boundary conditions. So this load and boundary conditions are interchangeable. We can apply loads directly on the geometry, or we can go for application of load in or directly on the mesh as well. So that all depends on the ease of modeling and how much we are going to get it from the model. And so we apply the loads, we get the boundary conditions, and then we choose the type of analysis which we are going to run. So in the analysis, let's say we are going to go for run a construction stage analysis. In that case, we actually go for construction sequence in the very first stage. We provide certain stages, like after 2 excavation sets, we provide concrete lining. Like after 3 excavation sets, we provide rock bolts. So after invert excavation, we provide rock bolts. So it is all depending on the type of construction sequence which we follow in the in situ case. In the site directly, we can simulate them in the construction sequence. and then we actually run the analysis. So in the analysis, it might be a construction stage analysis, it might be an like a seepage analysis, it might be an slope stability analysis. We choose a certain type of analysis and we proceed further, and then we go for results displaying. So once analysis is done, it's like a post processing. We can get the results in the form of tables, in the form of graphs, in the form of like a contour map as well. So you can find all the results, and how to export and how to extract the results will also be seen in the upcoming sessions. So the very first step is a geometry. So we'll be dealing with each and every aspect of workflow in the upcoming slides. The first aspect is about geometry. So most of the geometry is the geometric commands present in GTS NX are like CAD based. So you will be actually easily accustomed with the geometric modeling, and it is very user friendly. So you can select the datum, you can select the work plane, you actually model a 2D and then extrude to form a 3D model, and later on you can actually model like a 3D tunnel. You can go for a 3D tunnel, or else you can go for a pile foundation. So once the geometry is done, you just go for your complete like simulation of your own project. So you can have all the CAD options incorporated in GTS NX. And these are the different import formats. These are different import formats. Like we can have, we can get the imports from in the form of DXF or DWG formats, or along with that, we can find the CATIA format, V4, V5, SolidWorks, and or, as I said, AutoCAD, DXF, both 2D and 3D. And you can even import HTEP, IGES, Parasolid, and ACIS as well. So these are the different import formats present in the software. So because of these import formats, the modeling will be done very easily, and even this type of complex geometry can be modeled very easily. So here in this complex geometry, we can have different stratifications, different layers, and different intrusions as well. So, and we got a dam and over it. So in order to model such a kind of complex geometry manually, it is quite time taking and vigilant. We need to be vigilant as well. But using the import formats, we can easily model this type of geometry very easily in GTS NX. And suppose, let's say we are actually dealing with a tunnel right now. Let's say we are having a tunnel which is changing its direction along the length, and it is not a continuous straight tunnel. So what we do is we need to model it using and sweep command in the software. What we do is we got a surface, we extrude the surface using a sweep option, and this type of solid will be formed within no time. Like it only hardly takes like 40 to 50 seconds. And because of this type of sweep options, you can able to model this type of complex geometry very easily. Here you can find the sweep option, and here we can find the sweep option. So basically you should know the guide curve. This is your guide curve, the center line of your tunnel. So using this center line of your tunnel, you can able to sweep the surface to form a solid like this. And because of this command, you can able to model the geometry very easily. And then one more interesting feature present in GTS NX is a terrain geometry maker. So in this terrain geometry maker, we are actually dealing with the contour map. Like let's say we are having a hilly terrain. So as shown in this picture, this is your hilly terrain, and I would like to model the hilly terrain. Let's say this is my hilly terrain. I'm having two tunnels in here. It's like a tunnel in a hilly terrain, like a railway or roadway tunnel. So in order to model this terrain, it actually takes a huge time for an engineer, because we need to know the coordinates, how it is varying in X, Y, and Z directions. So what we do is we take a contour map of this particular area, and using this contour map, we develop a surface, and using this surface, we develop a terrain. And how about the layers? So we have bedding plane wizard for it. So what we do is we input the borehole data in the bedding plane wizard, and using this borehole data, we get the surfaces, and this is your layers. And these layers, along with this layer, this surface, you'll be forming the entire model within no time. So basically, you're dealing with the contour map of the hilly terrain, or any terrain. And also you can able to generate the contour map of any terrain using Google Map as well. So Google Earth, go to Google Earth, and you can generate the contour map using Google's sketch software, and then you can directly import it into Terrain Geometry Maker, and you can proceed for analysis. So as simple as that. And yeah, that's it. So, and the next step of geometry is material models. So we are having different material models present in GTS NX, and these material models basically serve for different purpose. So let's say we are having elastic materials. So most of the elastic properties are being given to concrete and structural materials. So we can provide elastic properties to the concrete material, and we do have a lot of plastic materials as well. So like a highly popular Morcum model is also present in the software, Dakar pressure, modified cam clay, jointed rock, modified moculum. So let's see the simple an overview about different material models present in the software. So let's say if you want to model an soil of linear elastic as well as a perfectly plastic, then I go for Morculum. So if I want to have a nonlinear elastic as well as nonlinear plastic like this is my nonlinear elastic and this is my nonlinear plastic, I can go for modified Morculum model. So depending on the type of behavior which we are interested, we can go for the material models. Suppose if you want to go for rocks, then we got a Hook-Brown material as well as generalized Hook-Brown material. Suppose I want to go for provision of joint data, then I can go for jointed rock mass. So there are different material models present in the software which are capable enough to provide and simulate the real-time situations in the software. And CWFS, which is widely used for tunnel modeling, is also present in the software. And for clay sands, where it is consolidation is quite predominant, we got modified cam clay, soft soil creep, as well as generalized S clay 1S material models. And for liquefaction analysis, we do have modified UBC sand. So once after definition of your materials, we go for meshing. So since this software is able to model 2D axisymmetric as well as 3D modeling, you can have all the features present in both the 2D as well as 3D softwares. You can have a 2D auto mesh generation, 3D auto mesh generation, and based on the dimensions of your complete tunnel, let's say an embedded solid inside and like a layered soil. So you can find fine mesh in the tunnel and near the tunnel area as well as coarse mesh on the boundaries, because this is the area where you can find stress concentration. So software can able to predict the dimension of your area, means because that's what we are modeling. So it can able to study the dimension and it can provide you with a fine mesh in here and coarse mesh at the boundaries. And apart from the normal tetrahedral meshing, we do provide GTS NX do have hexahedral elements as well. We call it as a hybrid mesh, as this hexahedral elements will be coming and dealing with the tetrahedral elements using pyramid element, because this complete we cannot able to model a slope using a complete hexahedron elements only. We need to have hybrid elements so that this hexahedron element will be converted to the tetrahedron using a pyramid element. So this hybrid mesh will be very much helpful in order to reduce the length of analysis, the time of analysis, and provide the accuracy in the results. As hexahedral mesh provides you with more number of nodes, it will be having more accuracy in the results as well. And then once you're done with the meshing, we go for a load applications. So in GTS NX, we are having static loads like a self-weight, force, moments, and even prescribed displacement as well. If you want to apply a displacement of 50 mm, so we can provide a 50 mm displacement, and instead of applying a load, we can apply the displacement as well. So pressure, water pressure, even temperature, and even pre-stress as well. So in case of your anchors where the pre-stress is predominant, we can apply pre-stress in the unbounded lengths of the anchors. And here we got dynamic loads as well. So in the dynamic loads, what are the different types of dynamic loads which we deal with with respect to tunnels? So we deal with the blasting. We deal with the seismic analysis in most of the cases. So we can actually run a seismic analysis by providing ground acceleration. We can get the blasting curve So this blasting curve using a certain blasting dynamic tool present in the software. So these are your different equations, and using these equations, you can provide this type of graph, and that can be applied onto your model. So you can run a ground seismic analysis. You can run a machine load analysis where the load is, like most of the cases, is the sinusoidal load, and we can run a blasting load analysis as well. And apart from it, we can even run a train dynamic load analysis in the software. So uh, as I said, there is a beautiful wizard present in the software, that is a tunnel and anchoring wizard. So in this tunnel wizard, what we do is we input the data. Instead of modeling a geometry and meshing it, we are inputting the data. We are inputting the dimensions of the tunnel, select the type of tunnel. It's a 3-center tunnel, or it is having invert, or it is not having invert. We just select the type of tunnel, and we provide the dimensions, and we go for shotcrete and rock bolts, and we provide the excavation sequence, and we provide the mesh size, and then software provides you with the complete model. Yeah, it's like a very easy approach, and about this we are going to deal with in session 4. And I was talking about the blasting dynamic load analysis. So here in the blasting dynamic load analysis, what we do is we can generate this type of blasting loads using the equations already incorporated in the software. So using the parameters, you just input the parameters, get the curve, and that curve can be applied at any point in here. And because of that blasting, what is the effect on my adjacent structures? So you're basically dealing with the dynamic analysis, and that dynamic load is a blasting load in here. And then once you're done with the type of loadings, you need to go for geotechnical analysis. So what are the types of analysis that GTS NX will offer you? And we'll see them now. So in GTS NX, you can able to run static analysis, both linear static as well as non-linear static analysis. You can run a slope stability analysis. So in the slope stability analysis, it can be applicable for both the 2D as well as 3D. That method is called strength reduction method. So we use strength reduction method to run a slope stability analysis. And then we got strength analysis method as well, SAM. So this is like a combination of both your LEM method as well as a finite element method, but this is applicable in only 2D cases. So we can even apply the SRM method in a construction stages as a check. So like let's say I'm having a hilly terrain, and I'm having a tunnel, so a tunnel excavation. So after certain excavation, I need to see whether my slope is stable or not. So I will run a slope stability analysis, and I would find the factor of safety. So and then next analysis, we got dynamic analysis. So in the dynamic analysis, we do have eigenvalue analysis in order to determine the natural frequencies of your structure. And then we can either go for time history analysis. Both linear and non-linear methods are present in the software. And we got 1D ground response analysis tool as well present in the software. So in the seepage analysis, you can run both steady state seepage as well as a transient seepage analysis. And then you can even run stress seepage coupled analysis. So whenever there is a coupling case, like what we do is we run a seepage analysis in the very first stage. We take the results of the seepage, and then we apply it in the second stage where we run a stress analysis. So the post stress of your seepage case will be transferred to the second stage into a total stress equation. So your total stress equation will be applied with the post stress from the previous stage, and your scenario of a real time can be analyzed using the stress seepage analysis. And we can even run a like consolidation analysis, so where you can simulate your consolidation cases, where like most of the cases where we run is we apply stone columns or we apply sand compaction piles. We are actually like modeling a behavior in the software, and then we can able to find the displacement with respect to time, as well as the pore pressure variation with respect to time. And this one is a construction stage analysis. So this is the main construction stage analysis, which we are going to deal with in the upcoming sessions as well. So here we deal with the stress analysis. If you are interested in, we can apply that in a seepage plus stress and slope coupled analysis as well. So you can apply a seepage analysis in one stage, followed by a stress analysis, and followed by a slope analysis in that same stage itself. So you can have a coupling analysis in the construction stage analysis. So the idea behind is soil is a very highly nonlinear material, and as the load changes, its behavior changes. So as your construction sequence changes, its behavior changes. So you need to basically go for a construction stage analysis in most of the tunneling cases, as we do have a different construction sequences. So let's say the results which you applied in an TBM method and the results which you got in the NATM method, both won't be the same. So you'll be having different results in both the analysis, because in NATM method, you're actually letting the complete tunnel to have a stress release, and you'll be finding the convergence of the tunnel. Actually, you're letting the convergence of the tunnel. But in the TBM method, we actually remove the like a soil or rock present over there. We excavate it and we directly provide the concrete lining. So because of these things, the construction stage analysis should be widely used in for construction of your tunnel. So the design of your tunnel or numerical analysis of your tunnel. So once you're done with the analysis, we will go for the results. So what are the different types of results which we can find from the software? You can get the graphical results, you can get the animated results, we can get the contour results as well. And suppose let's say we are dealing with a 2D tunnel now. So here we got a 2D tunnel, and I want to see the bending moment or any structural forces at only one particular section. So what I do is I'm having a section diagram. I will provide the plane of the section diagram, and I can get the result only at that particular section. And at that particular section, I take the bending moment, I take the shear force, and I will go for, and I take the axial force as well, and I go for capacity curves at that particular section. Similarly, at each and every sections of our interest, we can provide like the capacity curves at different sections. So that's how we deal with intersections as well as normal section of main tunnel as well. So that's all about the software in a brief way. And then we see the project applications. Yeah, so in the project applications, the very first thing which we'll see is some project applications related to tunnel. So let's say, as I already said, we have many applications of tunneling, as well as the pile raft foundations, as well as the shoring. So I will be giving you a brief idea about different applications in this project application section. So here, let's say I'm having an hilly terrain. This is my slope, and I'm having a shaft along with the tunnel, along with the cross passage and two main tunnels. So basically, you're modeling the complete scenario with the rock bolts as well as shotcreting as well. So once you model this, we are going to model this kind of thing in shaft session, as well as at a hilly terrain road tunnel session as well. So here we can find the displacements, we can find shotcrete stresses, we can find rock bolt axial forces as well. So using these shotcrete stresses, that means the structural forces, we can go for a generation of your capacity curves or characteristic curves. And here, this is actually a real-time project, and the previous example was also a real-time project. And in this real-time project, we are dealing with the Busan subway line. This is located in South Korea. Here, what we do is this is our the piers which you are actually seeing on the ground surface, or actually piers of your bridge, and underneath the bridge you're actually modeling and you're actually creating an tunnel. So because of this tunnel excavation, what is the effect of your tunnel onto the adjacent structure like bridge is being studied in this project using GTS NX. So this is the plan, and here this is a subway, and we got certain what I said, bridges they present in that section. So what happened was with the preliminary design, what they considered, they found that there is a differential settlement in the pier. So which is not possible when we go for in a reality case. So what they have done is they have provided, they improved the case, and they provided more shotcrete lining and more like your sections of rock bolts as well. And now it is safe, so we can find the flexural axial flexural stresses. That means your shotcrete bending moment as well as your structural forces like axial and shear forces. And then we go and get the axial forces in the rock bolts as well. And again, we take them and we provide the characteristic curve so that we can see whether it is the concrete can able to take that load or not. And then apart from the tunnels, we can go for soft soil or embankment cases. So here we can provide a consolidation analysis with SCP drainage, like a sand compaction piles drainage, and we can see how the settlement or pore pressure is being varied with respect to time. And we can have a slope stability analysis. So basically slope stability analysis in a hilly terrains, it's like a cut and cover method which we go for. And here it is cutting, the excavation is being done in different stages, and we need to find whether in each stage the slope is safe or not. What is the factor of safety in each construction stage? We don't need to develop many number of models for this scenario. We can develop one single model, and we can find the factor of safety in each and every stage. So this is my in situ stage, and I can find the factor of safety. And after one excavation, again, I can find the factor of safety. After other excavation, I can find the factor of safety. So the thing is, you can find the factor of safeties as well as the failure surfaces in each and every construction stage. So that's how we proceed with the one single model and more details in a single model. And this is also real-time project. Actually, here we got an hydroelectric power station, and this is a slope stability scenario which I'm going to tell you now. So here, this is my hydroelectric power station, and actually it is present very next to the like a hilly terrain. It's actually present in the valley. So because of this construction, and this is vulnerable for a landslide. So the client had done for initial condition, what is the factor of safety and what is the displacement contours. And after the excavation and after presenting the retaining wall in step-by-step manner, this is your final excavation. What could be the displacement contours as well as what could be the factor of safeties. So this is the initial condition model, and this is a final model. Here you can find in the displacement contour, most of your like a displacement are actually into your hydroelectric power station zone. So now the power station is like completely destroyed. So here, when we go for a retaining wall in step by step, we can find that displacement contour is only concerned only at the top, and now your power station is safe. So apart from slope stability, we can also deal with the foundation. So we can have a pile foundations or a pier foundations or pile raft foundation or a shallow foundation. And we can find even run and well foundation scenario as well. So all types of foundation, both shallow and deep foundations, can be modeled using a GTS NX. So this is one more project, real-time project. This is a Pentonium residential tower in Dubai. In the very first preliminary design, they go for a friction pile, and they found that they are getting the depth of pile of like around 40 meters. So because of that huge, it actually it is uneconomical. So they went for a pile raft design. So they had chosen for analysis, they had chosen GTS NX, and they went for pile raft design in analysis and design in using GTS NX, and they found that because of the raft being placed and because of the raft being considered, they found that there are like around 480 number of piles, and the length of the pile has been considerably reduced. So if the length of the piles has been reduced, how much amount of concrete and how much amount of steel has been saved for the contractor. So we can even model this type of scenarios, and we can run a parametric analysis easily using GTS NX. So we can find settlement contours, pile axial forces, bending moment in a raft as well. So raft we are modeling as a 2D a shell element or a plate element, and using this raft, you can even find the bending moment on at any section. Like as I already said, by cutting a plane and get the bending moment diagram at each and every section of your interest. So the next application is shoring and excavation. So in a shoring, we can go for a diaphragm wall, we can go for a retaining wall, we can go for a secant pile, we can go for like a lateral support system, considering both the sheet pile, valves, struts, anchors as well. So here you can see there are struts, there is a diaphragm wall, and you can see there is a tunnel in here, and we are having a subway station modeling. So there is an excavation, there is a there is a tunnel excavation very next to it, and there is a deep excavation for it, like your uh, metro station. So basically this type of analysis can be done very easily using GTS NX. So this is one of the application, real-time application using GTS NX for a shoring case. So this is an ODN tower. Here we can see this tower is being was already built, and was built on a hilly terrain. And here, this is the excavation area which needs to be excavated so that the building can be constructed. Here we can see villas, high schools, and there are many surrounding buildings present over there. So, but because of this huge excavation, these areas and these buildings will be vulnerable for a landslide. So we need to provide certain support so that there won't be any landslide. So they went for anchors and they went for diaphragm wall, and this is how they can find the results. So they're very meager lateral displacement, and we can find there is a settlement, but it is under control. So we can find a settlement in zones. The plastic zone is finally concerned like underneath the soil. That is, it's a settlement, and we can see most of the lateral displacement is under control. And then apart from shoring, we can go for hydraulic and underground structures. So in a hydraulic, we can go for a CFRD stability analysis, nothing but concrete faced rock fill dams. We can go for a seepage analysis for embankments, and like a cut and cover method for an underground driveway, let's say a subway. And one more application that is for dams. So this is a real-time application. It is actually in Buhang Dam in South Korea. It's an earthen dam. And here they went for construction stage analysis, and they have considered coupled analysis as well, so that they can find a seepage results as well as a stress results. So what they went is, in the very first stage, it's like a metal banking height of 150-meter, and then they go for next stage, and they went for a banking of 210 meters, and they applied hydrostatic pressure. So in different construction stages, with respect to the reality case, in different construction stages, they applied the hydrostatic pressures at different heights. And then they found the total displacements, horizontal displacement, vertical deflection, hydrostatic pressure. So this is all related to your stress analysis results. Apart from it, we can even find the seepage results, like what is the head, because it is an upstream and this is a downstream, what is the head difference, and what is the hydraulic gradient, and what is the flow path. So this is my upstream. So water will be going from upstream to downstream, and what is the flow paths, and what is the flow quantity as well. So you can find flow quantity, and you can find flow direction, and even you can find the equipotential lines as well. So these are all related to your seepage results. So in one single model, you can able to run about the seepage analysis as well as a stress analysis, and in a construction sequence. So one more analysis, it is called dynamic analysis. And in the dynamic analysis, as I said, we can go for a seismic analysis. And apart from the seismic analysis, we can even run a train live load data, train live load analysis as well. So when we go for high-speed railway trains, we cannot consider as a static load, because railway load is such a type of load which changes with respect to time and with respect to space as well. So in order to consider the different train loads, we are having a table, we are having a wizard called a train dynamic load table. So what we do is we select the type of train and we provide the velocity. So the software will calculate the variation of your force or variation of your acceleration with respect to time, and then with respect to space as well. So at different points, you'll be having different at different points, we can have different points of forces, and these forces will be applied from one point to other point, and you can see the variation you can see the variation of your displacements, you can see the variation of stresses in vertical directions, lateral direction, and later on you can even go for the substability analysis. So what is this factor of safety after providing my dynamic live load analysis? So these are the different applications in a very brief way. And now I'll be telling you what are the requirements of the software. So we actually recommend this column, and software can able to run even in this column as well. So the CPU is should be of a 64-bit, or we can and the RAM is of a 4 GB, and recommended is a 16 GB or more. And if the hard disk, it is better to have a more hard disk space, because finite element modeling takes a huge space and huge time as well. So in order to have a more space, it's always recommended to go for more than 1 terabyte, because if you deal with more number of models, it's better to go for recommended is 1 TB. And if you're so in order to so actually GTS NX, we are having a special feature, and we actually control the speed of analysis. We can either use the graphic card, we can go for strengthening the speed of analysis by using graphic card, or else we can use the number of processors as well. So but if your software is like a quadra-core processor, you can provide 4 processing, and you can enable GPU as well, so that the speed of analysis will be high. So it's very flexible, and you can find the software very user friendly, and get the analysis done within no time. And now this is all about this first session, and I will just provide you a little more details regarding the license activation, since most of them are interested in license activation. So I'll be providing you a simple idea about license activation once again. So you might be given with the 3 months license. So those who are not being given with a 3-month license, please go to en.midasuser.com and register yourself to get the license and to get the link for the software download. And so whenever you install the software, you go to options. In the options, go to license tab. In the general, you go to license tab. So once you go to license tab, it will be asked with the authentication method. So either standalone or web authentication. So you're being given with the web license, you go to web authentication. So later on, you need to provide your user ID and password. So user ID and password, you need to create in en.midasuser.com. So please create your user ID and password, and the same should be inputted in user ID and password columns. Later on, you're being given with the license key. So here, the PKID refers to the pre-post key. So enter your license key of a PKID in here, and then there is a solver key as well. Enter it in the solver key column. Later, just go to options. So click on options, and then you'll be finding the pre-post drop-down and the solver drop-down. You're actually selecting the PIDs now. So you're being given with the PIDs. So this is your PIDs. So in the drop-down menu, select the PID corresponding to pre-post, and select the solver corresponding to, select the PID corresponding to the solver as well. And later on, select all. You are being given with the advanced version, so you can have all the type of analysis getting run, and then press OK. So that's all we can do from in the form of a license. So thanks for your attendance, and until next time. So for any queries or any suggestions, please mail me on harsha@midasIT.com. Yeah, thanks for your time.